Hello everyone, we will present our technical notes under the title Analysis of the Most Feasible Offshore Nuclear Power Plant for Indonesia. Initially, our members are Ahmad Nugroho, Asyifa Rizki Daffa, Rafi Fadlurrahman, Gregorius Donny Setiawan, Maulani Puspita Anggraeni, and Salma Nur Azzizah from Nuclear Engineering 2020. In this presentation, we are going to talk about offshore nuclear power plant in general, the type of offshore nuclear power plant with their advantage and disadvantage on each type, approach from the geographical situation of Indonesia, and comparing for the most feasible type of offshore nuclear power plant for Indonesia.
So first of all, I want to explain about the definition of ONPP. In this new era, nuclear energy is familiar enough in the middle of the big globalization, including offshore nuclear power plants or ONPP. ONPP is one of the type nuclear power plants that located in the ocean. ONPP was created to possibly increase the movability aspect. So why we should use ONPP? Because ONPP has a high effectiveness value if it is to be moved. ONPP use seawater as its cooling system. They may have a more positive effect on public acceptance than nuclear power plants, because they can locate far from residential areas. Also, the use of ONPP is very suitable for use in the Indonesian Ocean. From this condition, energy exploration can be carried out optimally and evenly.
So, offshore nuclear power plant has three types, and I will explain each one of them. First type is called floating type, and the second one is gravity-based structure type, or you can call it GBS type, and the last one is submerged type. First is floating type, or you can call it offshore floating nuclear power plant. It creatively combines state-of-the-art light water reactors and floating platforms similar to those used in offshore oil or gas operations. You can look at the picture here. Offshore floating nuclear power plant is a plant that can be entirely built within a floating platform in a shipyard. It is also transferred to the site, where it's anchored within 12 nautical miles or 22 kilometers off the coast in relatively deep water greater than equals 100 meters and connected to the grid via submarine transmission cables. However, each types have their own advantages and disadvantages. There are three advantages of floating type. First is, floating type is transportable and movable. Second is, it's free from limitation of water depth, so that's why it can be anchored within 12 nautical miles and deep water greater than equals 100 meters. And last is, it's relatively cost effective. But floating type has also disadvantages. First is, it requires tranquil sea areas, and it's easily affected by the ocean environment such as tsunami or even earthquake. Second type is gravity-based structure type. Gravity-based structure type, or you can call it GBS type, are typically made from steel reinforced concrete in dry docks and tucked to the destination site after being floated. That is, GBS are transportable. You can look at the picture of main concept of GBS type nuclear power plant here. The GBS is designed as rectangular structure for ease of construction. Instead of developing a new design for the plant layout and nuclear reactor systems, the existing plant layout and system of the lane-based ONPP APR 1400 are used. Of course, GBS type has its own advantages and disadvantages. The GBS type is also transportable just like the floating type, but the GBS type has a high structural safety, unlike the floating type that is easily affected by the ocean environment. It also provides a land-like condition, and it's possible to mount very heavy topside plants. Unfortunately, the GBS type has a limitation of water depth and its lower cost effectiveness. The last one is submerged type. This submerged reactor uses the small pressurized water reactor technology, which is similar to the French submarine reactors. DCNS in France is developing a submerged type of offshore nuclear power plant named FlexBlue. What you're seeing here is FlexBlue, and FlexBlue is a submerged, cylindrical, fully modular, and transportable ONPP. It would be installed on the seabed at a depth of 60 to 100 meters at a site of 5 to 15 kilometers from the shoreline. Undersea cables would bring the electricity to customers, much like from offshore wind turbines. The advantages and the disadvantages of submerged type are a bit different from the other types, but the submerged type is also transportable just like the other ones. And it's also relatively free from the limitation of water depth, and it is invisible. But the disadvantages of submerged type are a bit much than the other. The first one, it requires a pressure vessel as a containing structure. The second one, it's difficult to control and maintain the entire system. The third one, relatively small electricity generation capacity. And the last one, it requires relatively long and expensive cabling system to land.
I will discuss the main technology used in ONPP and the ability of ONPP to solve energy problem. The first main technology used in ONPP. Basically, ONPP development is based on two pre-existing technology, namely light water reactor and deep sea oil platform. The light water reactor is a type of thermal neutron reactor that uses normal water as opposed to heavy water, as both its coolant and neutron moderator. Furthermore, a solid form of fissile element is used as a fuel. And the deep sea oil platform is a large structure with facilities for well drilling to explore, extract, store, and process petroleum and natural gas that lies in rock formation beneath the seabed. Next, ONPP to solve the problem of electrical energy. At this time, the demand for electrical energy is increasing along with the population increase of the world population. In Indonesia, most of the electricity needs are supplied by PLTU. But every day, the amount of PLTU fuel, namely coal, is running low. Based on this, offshore nuclear power plants are an interesting solution to solve this problem.
The next slide, it's about issues and challenges of ONPPs. Issues number 1, it's about construction and deployment. The ONPP can be built in centralized facilities like shipbuilding in the yards, and also can be built in sea. Because of that, the ONPP's deployment will be hybrid. Some of these ONPP's construction jobs can be done simultaneously. In the end, the total period of construction will decrease and will faster than land-based NPP. Issue number 2 is tsunami. The main cause of Fukushima accident in Japan is tsunami. Because of that, the new concept of an ONPP will be designed more safely than ever, in this case that caused by tsunami. Issue number 3 is marine collisions. The offshore infrastructure like ONPP will be easily damaged by sea waves or even hijacked. Because of that, this issue should be carefully considered and the infrastructure should be boosted. The next issues and challenge of ONPP is earthquake. An earthquake would affect ONPP, especially GBS type, that has structural integrity to the ocean floor. A base isolation system was introduced to reduce acceleration by adjusting the total weight of the GBS type that has long been applied in land-based NPP. Next, physical protection. Since ONPP are located away from land and have a minimum security, physical protection from external threats can be a challenging issue for offshore infrastructure. In this case, is ONPP. Especially underwater attack and delayed time to take security measures from land should be considered. Hence, improved physical protection and measures are required. The sixth issue is reliability and maintenance. The availability of power plant plays an important role in economic competitiveness. High reliability can be achieved with design simplification, provision of enough operating margin, and planning extensive periodic maintenance. The seventh issue is human error. Because located in the ocean, ONPP should be designed to minimize human error. Since the working environment of ONPP will be more stressful for the worker, and the limitation human resources that work in ONPP, it's more likely that ONPP workers can make mistakes. Thus, the component of ONPP should be an automatic component or something else to reduce human errors. And many more issues that I can explain one by one. There is a picture that compares the duration of the deployment of ONPP and land-based NPP. The picture shows that ONPP deployment is faster than land-based NPP, same like what I tell you before.
Capital cost. In general, capital cost of ONPP is high. We need about $3 up to $4 billion per 1,000 megawatt installed capacity. Due to many components such as heavy structure and high pressure component, which need wiring and steel in a big amount. The construction times takes limited 3 to 4 years, therefore to decrease the financial risk from interest payment during the construction, which can add up to 40% of the cost. Market potential of ONPP. The first classified is countries rich in domestic oil and gas that would prefer to export their energy products. This classes you can find it in Middle East countries such as Saudi Arabia, Qatar, and Bahrain. The second classes is country with high seismicity, high coastal population density, and limited domestic energy resource. Most of the countries is in East and South Asia such as Chile, Vietnam, Philippines, China, and Japan. The third one is countries with small grants and high prices of electricity, which you can find it at Africa and South America. And the last is potentially large mining operation and small country, which you can find it in small country in Pacific or even US. The next one is Indonesia's ocean characteristic. Indonesia has total sea area of 3.2 million square kilometers, which has potential to build ONPP. The Indonesia archipelago, located at boundary of major tectonic plates, Indo-Australian plates, Pacific plates, and Eurasian plates. The collision points of these three plates stretching from West Sumatra to Papua in the east. Related to seismicity in the region, Indonesia has high earthquake hazard and high tsunami potential. Due to geographical situation, the atmosphere, ocean, and feature of Indonesia Sea are affected by monsoon situation, Pacific Indian Ocean connection, and local phenomena. The last characteristic of Indonesia Sea is low frequency intensity storm. Indonesia located in equator. Based on consolidated history of tropical storm path over past 50 years in Asia-Pacific region, the area along the equator largely unaffected by major storms.
So now we have come to the conclusion. What is the most feasible type of ONPP for Indonesia Sea? There are three types of offshore nuclear power plant, that is floating type, gravity-based structure type, and submerged type. Each has its own strengths and weaknesses. If a type of ONPP wants to be built in Indonesia, considering the geography of the Indonesian Sea and without considering Indonesia's political condition, the GPS type or the gravity-based structure type will be the most feasible type to be built in Indonesia, specifically in the Malacca Strait or the Java Sea. It had some reasons until we finally chose the gravity-based structure type as the most feasible type of offshore nuclear power plants to be built in Indonesia. Although the cost effectiveness is lower than the other type, this type is a good startup for Indonesia to build a nuclear power plant. GBS may also have a limitation of water depth, but considering that it already has a high structural building, safety wouldn't be a problem. Finally, we would say thank you to everyone who has listened to our presentation attentively. I hope that our materials will be received properly. Last but not least, thank you for your attention. Have a nice day.